Hi there, welcome back to the course. In this section, we'll begin the process of understanding light in studio photography so that we can improve the light, we can do some things to the light in order to make it work for us in a better way, and that will help us improve our portraits. So let's start with the first video here, which is going to be on the inverse square law of light. Now I know it sounds a bit technical, but once you see the demo which is about to follow, the exercise that we'll be doing in the studio room in this video is just a very simple concept. But let's first understand this in a technical manner. So first of all, what is the inverse square law of light? So it's represented by this diagram here, which just says that the intensity of the light is equal to 1 by square of the distance. Now don't get confused by this. All this means is something which is very natural to understand, which is that as you move your subject away from the light, it's just going to receive lesser light, right? Lesser intensity of light. So as you increase the distance, the power of the light falling on your subject reduces, or the intensity of the light reduces, and just very easy to understand. This formula just gives you the exact power. So for example, if your subject is at 1 unit distance, let's say 1 meter, 1 foot, then it's going to receive, let's say the full power, which is represented by 1. And if I were to just move it to, let's say 2 meters or 2 feet, then the drop is going to go to 1 by 4 and not 1 by 2. So we would naturally assume that, if you were to double the distance, the light should become half, but that's not the case because it's distance square. So it's actually going to go to 1 by 4 and so on. But trust me, this is not really important to us, because this is more important, let's say if you are doing some really high-end commercial photography and you have to absolutely nail your exposure and you should know exactly what is the intensity of the light. But we've already seen we are not really interested in that. We are okay with the trial and error approach, but you should just know this, right? But what is more important to us is that what are these numbers here? This is more important to us. Now these numbers here represent something similar to this only, but they represent by what percentage is the light falling off, or the concept of light fall off. Now why is this important? Because if you notice, what's happening here is that things are not really proportional. So if you notice that if your subject is right here, very close to the light at 1 unit of distance, it's getting 100%, and if you move it behind, the drop in light is 75%. So if you had, let's say, 2 mannequins like this, one behind each other, what's going to happen is your first mannequin, if you expose your shot for the first mannequin, that is receiving 100% of the light, but the mannequin behind it will receive only 25% of the light. Therefore, it's going to be underexposed as compared to the first mannequin by 75%. So it's going to be 75% more darker than your first mannequin, right? But if you were to move them right here, just give me a second, please. All right. Now, if I were to move this mannequin right here, and this mannequin right here, so this is at 9 and this is at 10 unit distance, the drop in these two mannequins is not too big. In fact, it's negligible, right? What this means is that if you were to expose now for the first mannequin, the second mannequin will not be too underexposed as compared to the first mannequin, because here the drop in light is not really great. So these two mannequins will be exposed almost they'll have like a similar exposure. That's what I mean to say. So can you see, just by changing where your subject is placed can have a massive difference on what is behind that subject. So for a moment, let's just get rid of this mannequin, and in order to understand this in a much more easier way if you're getting confused, and let's see another example, because this is exactly the demo that we'll be performing when we do this particular exercise. So what we're going to do in this demo is that for our first shot, we will be moving our mannequin really close to the backdrop and away from the light source, just like you can see in this image here. And then we're going to be taking a shot by exposing for the mannequin. And what you'll find in this shot is that the backdrop, it comes out to be white. That is, it is exposed properly. Why? Because since this mannequin is away from the light, there's not really going to be too much of a difference in both the exposures for the mannequin as well as the backdrop, right? But for the second shot is going to be the interesting shot, because what we're going to do is we're going to move this mannequin in front of, right in front of the light, very close to the light. And what you'll find is, because this is very close to the light, now the light fall off between the backdrop and the mannequin is going to be huge, right? Because we've seen that if your subject is close, anything behind it starts to get really underexposed because of the intense light fall off that happens only in the beginning. As you move away, the light fall off becomes lesser. So now these two are at the extremes. So what's going to happen is, if you expose now for the mannequin, the backdrop will be severely underexposed. And what's going to happen in that case is that even though this backdrop is white, it'll actually look dark gray in your shot. So just by knowing this rule and making your subject go closer, you can get two completely different looking shots, like we'll be seeing when we take these two shots in the demo and we compare them. So if you're getting confused right now, don't worry about it. It's just better to do this and through the demo and learn it that way. So what we'll do right now is, let's go to our studio room, let's take these two shots and see what the differences are. So let's go there. Alright, so now that you know how the inverse square law of light works and we've seen the important concept of the light fall off, let's actually put this into practice by taking two shots where I'll be using this mannequin. So what we'll be doing is that for the first shot, we'll be actually placing this mannequin really close to this white backdrop that we've got this time. And for the second shot, what I'm going to do is that I'm just going to bring this closer to the light. So something like this. And what's going to happen is that we've already seen that when your subject is close to the light, then the light fall off to anything behind that is really, really huge, right? So what we're going to find is that when we take this shot with the strobe light close to our mannequin, what's going to happen is that even though this backdrop is actually white, this will actually turn out to be dark grayish or grayish in color. So that opens up a lot of creativity channels for you, because you don't have to always change the color of the backdrop. You can get different types of portraits with different colors of the same backdrop, from the same backdrop. So we'll find that when we take this first shot, we get this really nice portrait where the mannequin is exposed properly, but the backdrop is not exposed properly. Why? Because the mannequin is close to the light. So there's a huge light fall off to anything that is behind this mannequin. So we'll be able to change the color of the backdrop. And for the second shot, when I actually move this behind like this, we've learned in that law that, when something's away from the light, then if two things are close to each other, like the mannequin and the backdrop, the light fall off is not that great, even though there is a slight, drop in light, but it's not great. So what we're going to find is that both the mannequin as well as the backdrop will be exposed properly. That means you'll actually see the white color of the backdrop. So just by moving the mannequin towards and away from the light, what we'll find is that we can dramatically change the look of this portrait. So we'll be seeing these two shots when I take these shots. Now, of course, we've also seen that as you move the subject away from the light or towards the light, even the light power that the subject receives, that is the amount of light that the subject receives, also changes. So there are two ways to correct this. One is, of course, that we've already learned in the flash exposure video that, for example, if I move the mannequin away for the shot that I'm taking, that'll be the first shot. Of course, what I can do is that I can increase the power of this light, because we've learned in the inverse square law of light that as the subject moves away from the light, even the power that it receives from the light decreases, right? So there are two ways to correct this. Either I can increase the power of the light, or I can just simply decrease the f-stop number like we've learned in the aperture section. So I'm going to choose the second way because it's much more convenient for me. So I'm just simply going to shoot the first shot in which the mannequin is away. I'm going to be shooting this at a lower f-stop number so that our aperture hole is open and we get enough of that light. And for the second shot, when I bring the mannequin closer to the light, I'll just be decreasing this f-stop number because there'll be plenty of light hitting the subject since it's close. So we'll just close down our aperture hole by using a larger f-stop number, and then we'll be able to get a good exposure. But we aren't really worried about the exposure here. That is something like we've already seen before. You can get it done with a bit of trial and error. Of course, it would be easier if I would have had a light meter with me right now, because then simply you just point the light meter towards the light source, and then I can know exactly what f-stop number to use, so I don't have to do the trial and error. But it doesn't really take too long. I've already practiced these two shots before making this video, and I know what f-stop numbers I'll be using, and I'll be telling you when I take these two shots what are the f-stop numbers that I'm using. Shutter speed is going to be at my sync speed 1/200, and my ISO is set to 100. So let's take these two shots. We're mainly concentrating here on the inverse square law of light and what kind of changes it will produce in these two shots. So our first shot, our setup is almost ready. Let me just place this towards the light, make sure my light is on, and I've got my transmitter. All right, so we are all set to take our first shot, and for this, since the mannequin is away from the light, I'll be using a lower f-stop number to just let in more light in the camera, because the mannequin is away, so it's going to receive less light. So I'll be correcting that through using a small f-stop number. So I'm using f5.6. I've already done this trial and error, and I've seen that at f5.6 this mannequin is receiving enough light. But what we're concentrating is what happens to the backdrop when we do this. So let's take this shot. All right, so we got our first shot. Let's look at this shot right now. Once I finish shooting, once I take the second shot, we'll actually be going in the laptop and we'll be comparing these two shots. But right now you can look at this shot. And for the second shot, what of course I'm going to do is I'm going to be moving the mannequin close like this, really, really close to the light. And what I'll be doing is, this time I'll just have to slightly go behind because this has come close. But I'll just be closing down my f-stop number a bit. So what I've seen is that at f13, I'm getting a good exposure for the mannequin. That's because we slightly want to decrease the amount of light coming in the camera because it's closer to the light. So let's do this. All right, so we have got our second shot also, and you can see here that this looks really, really different to the first shot. So what exactly is happening here? Let's try to go inside the laptop and let's try to analyze these two shots. And what you're going to learn is that not only did the backdrop color change, but something else also has happened, which is a difference in these two shots, and that is also important to know. And that has again happened because of inverse square law of light. But that's tough to explain like this. It's better to just show you this in the laptop, and that is the time when I'll be explaining you that apart from the backdrop, what is the second change that has come in this particular shots or between these two shots. So let's go there. Okay, so this is our first shot, and as explained to you before, you can see that the backdrop is white in this. That's because the mannequin was far away, therefore there isn't much of a light drop between these two, so they're exposed similarly. And if you notice our second shot, you can see this time the mannequin was close to the light and the backdrop was really far away. So of course there's a huge light drop off, and that underexposes our background and makes it gray. So these are two totally different looking shots just by changing the placement of the mannequin with respect to the light. But the second thing that I want you to pay attention to here is just the look on the mannequin's face. So if you look at this shot, you can see that there aren't too many shadows here. That is, her face is pretty evenly lit, and this doesn't really make for too interesting a portrait, because what we like in photography is we like a bit of a depth in our shots. So if you look at this shot, you can see that this right part, the left part of her cheek is, where the light was coming from, is stronger, and then we have these shadows, and this just gives a more dramatic look to the shot. So this type of lighting where everything is similarly exposed on your person's face, this type of lighting is called as flat lighting, and this is called as dramatic lighting. And flat lighting is usually not preferred, and we kind of prefer dramatic lighting because of the depth that it gives. But why is this happening? So you can again think of the inverse square law, and let's consider the two cheeks of this mannequin to be subjects, like small subjects themselves. In that case, this subject is ahead and this is behind, and since this is closer to the light, what did we learn? That if the subject is closer to the light, the thing which is behind is going to be underexposed. So this cheek is going to be more underexposed as compared to this. That's because this is closer to the light. Whereas in this case, because this cheek is farther away from the light, therefore there's not going to be enough of a drop of between these two, like not a significant drop in light or a light fall off. Therefore, they will be exposed almost similarly, and this gives them an like a even or a flat look, whereas in this case you get this nice transition from highlights to shadows and it just looks better. So in a nutshell, if all this is proving to be very technical or confusing to you, what I can do is I can just summarize this by telling you that place your subject closer to the light. That's all you need to know from whatever you've learned till now. Now, this doesn't apply to every situation, let me be very honest, because you never know. Sometimes you might like flat lighting, but I'm talking on an average basis. We would like a bit of depth to our shot. So in average cases, it's better to put your subject close to the light. Now, whatever you learned in this video is important, of course, but in the next video, which according to me is the most important video, even though inverse square law of light just sounds like it's the most important video, but it's not, because the next video is very important, because that's where we'll be learning about how to turn hard light into soft light. And again, in that video, you will be learning that it's better to place the subject close to the light. So that's why it's usually better to place the subject closer to the light, because now you know that as far as the inverse square law of light is concerned, you gain this advantage of having more depth to your subject. Of course, there are other factors also. For example, the angle of the light also plays an important part, because if you were to fire this light absolutely straight to the subject, then these two cheeks will be in the same plane. So we won't be able to, even though your subject might be closer to the light, we may not be able to see this because they are in the same plane. But because we're firing, and we usually fire the light at a slight angle, getting your subject close to the light will produce this effect. And like I told you in the second video, in the next video, we'll again be learning that there's another reason why you should place your subject closer to the light. So I'll see you in that video. Bye for now.